You can see that we have placed this piston hydraulic cylinder back in its zero position. We are hoping to get you to see in 3 dimensions if this hydraulic cylinder rotates about this shaft, it will allow this yellow toe support structure to move in this direction. The toe structure is anchored at the back by these 2 swing arms, these green swing arms, so that when the toe structure moves forward, the distance between this point and that point stays the same. So this green arm will rotate forward and this green piston will rotate forward. We are attempting to get you to see motion in 3 dimensions. We do have the ability to select this hydraulic cylinder and select this foot plate and select this reinforcing plate and select the rest of the structural member of the foot. And since we've selected them all together, then they're going to exist as a group. We can then bring in our rotation tool and place it on that rotation axis, and we can move the foot forward and backwards. And we bring to your attention that when we move the foot forward and backwards, let's move it forward 6 degrees, that this spring compensated shaft is no longer accurately connected to this foot plate shaft. And so in order to bring all of this back into proper alignment, we would also have to rotate this shaft forward. And surprisingly enough, you see that rotating this shaft forward does not allow it to be in the same configuration that it was in before. This demonstrates one of the issues associated with 3-dimensional drawing programs. You can only alter one set of parts at a time. So now we bring this foot plate back up to bring the connection back to where it was. And even though you see us doing this as a series of movements, the truth is that all of this activity would happen at the same time in a physically real structure. It's just not possible to demonstrate that in a 3-dimensional drawing program. You can see now that from a viewpoint method of looking, we've pretty much aligned all of these structures back up to where they were, other than that this green swing arm would also need to be brought back into alignment. With where it originally was. Again, you can see that the shafts are not perfectly aligned, but it allows us to show you the point that we're trying to make, which is now you can see that the right foot, little toe, foot support structure. This structure right here has been moved forward with respect to the right foot, big toe. And because of the way this is put together, the various different connections that are holding it will make it so that when we move this right foot structure forward, it tilts up the toe. Now, if the foot had any weight on it, then this foot toe plate of the right little toe would actually remain flat on the ground because it has weight on it, which requires us to put it back to this position. In order for it to be in this position, we have to rotate this spring-loaded shaft back down until it's lined up with that toe. And then we have to take the What we're demonstrating is this right foot little toe spring piston has rotated back down to line up with this shaft, but it needs to have this part of this toe piston extended. And so we can select the lower part of this piston and bring everything into view. We'll see that this is lined up on the red axis, so we can move this down using the red axis. And you'll notice that the effect this had of bringing this piston back essentially into alignment with where it would be, because this connector is connected to this shaft. The effect is that this shaft moved inside of this cylinder, and with this spring would have been compressed in order for this shaft to move down. And the final end result of that is that in order for this right little toe to move forward, if it's holding weight, it's going to resist doing that based on the compression power of this spring. On the other hand, a converse way of discussing this is that if a shock load occurred on the piston robot, where basically the leg, ankle, and piston robot went backwards and the right little toe was on the ground, then instead of transmitting a giant shock load into this toe, what would happen is, as this entire piston robot went backwards and the toe stayed on the ground because it's supporting weight, instead of transmitting a giant shock load throughout the piston robot, all that would happen is this spring-loaded connecting piston shaft would compress this spring. The end result of this is that you have a protection effect for the robot to absorb shock loads. We will bring to your attention there's a possibility our computer may have a little blue alien living inside the computer. We asked him if he would help us to show you the name of the next video in our series about PistonRobot, and he said, sure.